So today's lesson is on the quotient rule for exponents. So quotient means we are dividing exponents. So we're going to start off with a basic example that won't even have exponents in it. So let's, for instance, say that I'm multiplying 4 times 4 times 4 and dividing by 4. Okay, so if I multiply 4 times 4 times 4, if I actually do all this multiplication out, I get 4 times 4 is 16, times another 4 is 64, divided by 4, I get 16 as an answer. Basically what happens, we know that multiplication and division are inverse operations. That means they sort of undo each other. So when I multiply by 4 here and divide by 4 here, they sort of cancel out and leave my answer as 4 times 4, which is 16, or 4 squared. So let's look at this pattern a little bit more. Let's say I have another 4 times 4 times 4, but this time I divide by 4 twice. So same thing, except now I'm dividing by 4 2 times. Well, again, this multiplying by 4 and this dividing by 4 are inverse, so they kind of cancel each other out. This times 4 and this divided by 4 cancel out, and what I'm left with is just 4. This can be written another way. This 4 times 4 times 4 is like having 4 to the third power. And when I divide by 4 twice, that's like dividing by 16, or 4 squared. So what we're saying here is that 4 to the third power divided by 4 squared is equal to 4, or 4 to the first power. The top example can be written in exponential form as well. So if I take 4 to the third power, I have 3 4's multiplied together, divide it by 4, or 4 to the first power, we found that that equals 4 squared. So what we're doing is we're trying to find a pattern here. Let's do one more example. Let's say I have 4 times 4 times 4 times 4, so we have 4 of them, and we're going to divide by 4 twice. Now in this example, I have 4 times itself 4 times, that's 4 to the 4th power, and then when I divide by 4 twice, like we said earlier, that's 4 squared. It's like dividing by 4 squared, or 16. So here, this times 4 and this divided by 4 cancel, this times 4 and this divided by 4 cancel each other out, and what I'm left with is 4 squared, or 16. I'm writing everything in exponential notation for now because it's easier to see the rule that way. So if you look at the 3 examples we've done when written in exponential form, you'll notice a pattern. Because every time we divide by a 4, after multiplying by a 4, it cancels out, what essentially happens is however many we're dividing by, we can subtract from however many we're multiplying by. And that's how many 4's we have. So if I'm, in this middle case, multiply by 3 4's and then divide by 2, 2 of these divisions cancel out and leaves 1 behind. Here I multiplied by 4 4 times, I divided twice, so what was left after 2 of these canceled with 2 of the multiplication is 2 4's were left. So the shortcut rule here is that we subtract the exponents, as long as the bases are the same, just like with the product and the power rule, the base has to be the same. So in other words, these were all 4's, the bases were the same. But the rule is that you actually subtract the exponents so that we can do bigger problems faster. So for instance, if I gave you 4 to the 9th power divided by 4 to the 5th power, you could simply write that as 4 to the 9 minus 5, which is 4 to the 4th power. And you can leave these answers in exponential notation generally like that. You don't have to actually multiply these powers out. And this works whether it's numbers or letters as long as it's the same base. So if I have x to the 12th power divided by x to the 6th power, we can subtract the exponents and I get my answer is x to the 6th power. So as long as they are the same base. Now division can be written one of 2 ways. We've been writing it with a divided by symbol. This can also be written as a fraction. So if I have x to the 12th over x to the 4th, that really means x to the 12th divided by x to the 4th. That means the same thing. A fraction's just another way of writing a division problem. And we can use the same quotient rule that says we subtract those exponents. And that becomes x to the 8th power. So whether it's written like a fraction or not, you can subtract the exponents. If it's written like a fraction, order matters with subtraction, so make sure it's the top exponent first minus the bottom exponent. So make sure you write it in order. Now we'll get into this in more detail later, but this does also work when you have a smaller number on top. So let's say I have x to the 3rd power over x to the 9th power. That means the same thing as the top, x to the 3rd, minus the bottom, x to the 9th, divided by, sorry. So that means the same as x to the 3rd divided by x to the 9th. And I can subtract those exponents, but I have to do the first minus the second, or the top minus the bottom. And I do get a negative number. So that actually does mean x to the negative 6th power. We're just subtracting the exponents. We should only be changing the exponents, not the x or whatever that number may be. We'll talk more about what negative powers mean a little bit later. For now, just know that you can have a negative exponent. Now, sometimes you'll have things with numbers. Actually, let me do a different number than that. Let's try 8x to the 5th power, y to the 3rd, over 2x to the 3rd, y to the 7th. So same rule applies. We're dividing, but we can only use the quotient rule on things that are the same base. So the x's with the x's, the y's with the y's. As far as the 8 over 2 goes, that still means the same as 8 divided by 2, or 8 over 2 as a fraction. So if it does go in evenly, you write that whole number. 8 divided by 2 is 4. If it didn't go in evenly, you would just write it as a fraction. So if it were something like 5 divided by 2, you would just write that as 5 over 2. And that's the number. But these aren't exponents, so we're not using a quotient rule here because they're not exponents. Quotient rule only applies to exponents. Okay, now we can look at the x's. So the rule is we subtract the exponents, top minus bottom. So x to the 5th minus, or divided by x to the 3rd. Subtract those exponents, and it's x squared. And the same for the y's. We subtract those exponents. Remember, top minus bottom. So it's y to the 3rd over y to the 7th. 3 minus 7 is negative 4. And for now, you can leave those answers like they are. Like I said, we'll talk more about negative exponents a little bit later, but for now, you can leave your answer just like that. And that's basically the quotient rule for exponents. So the rule is for quotients, anytime you have a fraction or division, you can subtract those exponents and leave your answer in exponential form.